let's just say, for instance, I took a cube of steel and I had the sharpest blade I could find. And I attempted to cut this steel in half. Why wouldn't the steel go nuclear? With one chop. Why didn't it go nuclear?
Right. Let me get what you mean by go nuclear, because on the surface it might appear not to, right? But when you're dealing with subatomic particles, you don't see the magnitude of what that impact is having, or that friction between what you're talking about with that connection. So when you start to look at the microscopic reaction and elements and the minute things, you may well say that
something happened down there.
Yeah.
Well, I've got two narratives, and I'd like, if some of the audiences are not that well versed in science, to try to get an idea of what it is I'm trying to explain. Let's just say that steel is made up of carbon and iron. And for our model, we're just going to use 5 carbon atoms and 6 iron atoms. And we're going to heat them up, cool it down, whatever. We're going to make steel. So that's the model we're going to use. 5 carbon atoms and 6 iron atoms. As that blade comes down, we could rattle the carbon atoms, let's say, and it may tend to want to move across to the other side, for argument's sake, leaving only 4 and 6 iron atoms, which isn't steel anymore. So what it tries to do is grab onto its carbon to keep with its strong attraction and keep it being steel, and the other side does the same. And if any iron atoms try to escape, which might lose 1 and become 5, it holds onto its iron atom as well. And as that blade comes down, they hang onto each other, and any violent shaking that knocks any metal loose, it's still steel on the bottom. Because if you look at the tip of the blade, it's got crevices the size of Mount Everest compared to the particles. You'd never cut that thing in half, which is what will constitute a nuclear explosion. So that is narrative number 1. Narrative number 2, we talk about the spaces between the atoms. Now, I'm not going to use the word space because I'm going to come on to that a bit later. Say gaps. We're going to use the word gaps between the atoms. Now, the moment the blade hits that block, it sends a shock wave, and that shock wave will take the least path of resistance, the path of least resistance. And it may seem as if you've gone straight through and whatever in the way you've hit it, and you think, wow, maybe I did hit a few atoms. But when you feel the side and you say, wow, that's smooth, look at it under a microscope. You see it's like the side of a mountain. It's very jagged under a microscope, where it's followed the path of least resistance. Now, I said 2 narratives. I want to give one final example. If I took a Tupperware bowl, like put sandwiches in, your lid and everything, and I filled it up with water, and I took frozen peas and I put it into the water. Now, the peas represent the steel molecules. The water represents the gap between the molecules. As I go to chop that in half, the peas simply move across to one side and the other side, and any that's left on the bottom, it's still in steel form. The truth is, the blade was in Europe and the atomic particles were in America. The blade was nowhere near.
Right, so obviously the way we teach in Wu-Sabat a lot of the times is based on questions and answers. One of the things that, given what you've just described, is that when we have a reading called the Atomic that Partner Bab Yanoun has given us quite recently in the last probably couple of years or so, which explains that although people look at atoms as if they're solid, even when you look at the periodic table, it's giving you the impression, even when you look at most things around us, it's giving you the impression that the atoms are solid when they're not. They're balls of energy, right? And when you're saying the space, the space, it's not really. It's hard to say it's not space, because then you'd have to explain, because you got space, you got matter, and then you got what people consider time. So say space, matter, and time, they kind of are a union and work together. They're inseparable. So what we're basically saying is, if you were to go deeper and deeper and deeper into the composition of what atoms are, they're just really balls of energy, which is held together by ether, as I think we spoke about the last time. Now, ether is the X factor, if you want to use that, because you have scientists who accept ether, and you have those who are still not in agreement with it, or they have some reservations about it, or they don't actually accept that it is what we say it is. So it's still controversial to some people, but this is where, we talk about, obviously, the different states of ether that come into the realm of quantifiable things when we start to look at atoms, and when you start to subdivide atoms into quarks, Zeelis or Ziads, as some people call them, to biaps. That's what I mean, that because you can constantly subdivide an atom to the point where there are now levels beyond what is quantifiable, it's almost like what you're saying, nothing is there.
Nothing is there.
So you're not really able to, I'm actually kind of emphasizing and aligning with what you're saying. So there's a part where we try to quantify and see things as if they exist and they're there and they should have these reactions, when on the other side we can also equally say they're not actually there, and the impact that they have is not necessarily visible, and it's also able to change. It changes. So it's like, for example, when it's being observed and when it's not being observed. So these are all these types of things that we have to take into account when we're dealing with atoms and dealing with things on that minute.
Could I just stay on that point about the ether and what people may interpret as space? Because I'm going to quote some mathematical figures now.
Okay.
And these are tests that were done. It's logged into the curriculum. You can look it up on the internet. It says that space, you're in deep space, has the capability to develop a magnetic field. It says that space has the capability to develop an electrostatic field. Now, let me just quote you those figures. The figures for magnetism is some 1.25 times 10 to the minus 7 newtons per ampere squared. That's what's quoted. What does that mean? Newtons. Well, the magnetic field that they say can be developed in space has a force of some 1.25 times 10 to the minus 7 newtons of force that can repel something magnet or can attract something. It's tiny.
Yeah.
The ability to develop an electrical field in space is 100,000 times smaller, 8.85 times 10 to the minus 12 farads per meter. Farads is the units of capacitance. It's telling you that per meter, you will get this amount of capacitance, which is very small, of the order of a million millionths. How can something have the ability to be developed out of nothing?
Okay.
It's impossible. Look at the speed of light, limited to 1,860 miles per second.
Right.
We can control light on Earth. We do by passing it through a glass cylinder. we tint the glass cylinder and it slows the light down by a few microseconds. It was used in early TV technology, so they could lock the pictures with the scan cycles and everything, so the pictures arrive at the right time on your TV, right? We use it for time delay. In my opinion, light was always limited.
Exactly.
Because it should not have been limited to 1,806 miles. What is doing it? There is something in space that they're not mentioning, that we cannot see, that is causing an electromagnetic field to be developed.
Okay, so when you say they say and it is said and the scientists, this gives this is one of the things that we contend with as Musbatu or Sabians, Nuwapians, is that you have academia who, if you study, and you mention Newton, for example, you can mention many people who for years have been the authority on these things, and they say this and they say that, and we are challenging those things, because what we're basically saying is that who gives them the authority to say this is what we should all accept? Because when you start to look at the greatest European scientists, whether it be Einstein, Newton, and all of these people that we have been taught about through, again, you mentioned curriculums in educational establishments or schools, it's all predominantly Western or European thinking. And they don't accept anything outside of what they consider to be academic. Because even when you're dealing with scientists, I was listening to when there was that debate between Terence Howard and I won't mention the others' names, but what they were basically saying is that because he is not accepted within the academia or the scientific community, then the questions they tried to ridicule him, and some people were basically saying, and this is not about him or anyone else, it's just the fact that just because something has been said and done for thousands of years means that it is what it is. So when we're saying, yes, you're right, like the speed of light is limited, and there has to be something that is limiting it. Of course, you measure the speed of light in various ways. In a vacuum, or like we say 186,272 feet per second, for example. But that does fluctuate depending on, as you said, how the measurement you're using and
to do it,
and how you're doing it. So we're saying categorically that limitation is based on ether, according to the information from Parnababianun in the reading called Atomic, which is it's ether that is actually limiting the speed of light. This is why no matter how fast the light travels, it cannot escape that darkness.
It can't escape it. It's amazing that after all these years of using these formulas, because I mean I've got students, and I must say a lot of them, if not 98% of those that want to study, have been very successful. And I teach them science, maths, computer programming, and I have to follow these academic statements that are in historically.
I guess my point, I was sorry to interrupt, is that there is distortion in what has been taught, because we're living in a like, you're using your mind, you're thinking, you're challenging, you're questioning these things, and this is what you're supposed to do as a scientist, because if we don't evolve science, then we will be stuck. So if something has been the same throughout a period of time, doesn't mean that it's got to remain that way, because by the fact that things are changing, more information is unveiled, there are people who want to know the truth. There are people who there are people who don't know the truth. And the people who don't know the truth, it's not necessarily because they just don't want to know the truth, it's because the truth has been distorted. So I was just saying that we have to get to a point where we realize that things are changing and evolving, and we're in a different day and time, and people are going to
We need to make
question.
modifications. We
Exactly.
need to bring them in because we've been getting away with it for too long because it seems to work. And then we're wondering why we're not advancing the way that we should be advancing.
Exactly.
Because once again, I'm saying that science is not going in the right direction fully. If I could just quote what Terence Howard said about the energy surrounding the nucleus. Right. Atoms and have electrons that presumably were rotating at the speed of light. That's sort of a bit far-fetched now, because what Terence is saying is that it's energy that's surrounding the nucleus.
Right.
It's just frequency, energy vibrating around there. And lo and behold, what did the most powerful microscope in the world see when it zoomed in on a silicon atom lodged on a piece of graphite? It just saw a cloud. It saw a cloud. That was the atom. Even the producer was taking photographs. They saw a yellow cloud. That was down there. And just to give the audience, if you're not really that versed in science, an idea of the depth of magnification used to see that. If you were in a helicopter and you were up in the air, say almost in space, and you could zoom in with a pair of binoculars into California, the west side of America, into someone's living room and watch them having dinner, then you might get an idea of the kind of magnification
that's
used
necessary
to see the atom.
Right.
Because all they could see was a cloud, a yellow cloud. My immediate reaction was, get a video down there so you can see the electrons moving around the atom and everything. And I said, stop, Neville, stop. It's impossible to get a video camera down there. We're using the finest particle we know to bring information back to us. And all we can see is a cloud of dust. And that is as far as science is concerned, Western science is concerned, that is the deepest they have ever probed into these subatomic particles. Nobody has even let alone seen that, let alone beyond it. What's down there?
Well, this is where, as controversial as it may be, we have someone who's teaching us and telling us that he's not from here. He comes from what you would call civilization that is light years away. And that's why people refer to beings like that as extraterrestrials, because they're extra to here. He's a visitor. He's not from here.
He's not from
and
here.
Technology, and that might sound trivial. Okay, he's not from here. Where is he from? That's important because of what you just said, that when you're dealing with interstellar traveling, or being able to say you're from somewhere outside of this known solar system or this galaxy, then you have to think what type of mathematics or what type of travel, how would you travel those distances to get here, right? So as an extraterrestrial from a planet called Risk, and it's in a galaxy known as Ilion, he's giving us information and teaching us information that is not commonly known to, as we said, the status quo, or like the Western scientists.
Western
and so when you come with things and challenge what has been taught for thousands of years, this is the same thing that, as you mentioned, Terence was doing, where they're like, you've got to be crazy, until they come up with it or they prove it, then, they're not going to take your word for it. But the reality is there are civilizations and scientists outside of the West that, the Western scientists, if you go back to the Greeks and the Romans, they went to ancient Egypt to study.
Yes.
And some of the information was kept a secret on purpose. And hence the pyramids we spoke about before, how they were built, and the intricacies in terms of the mathematics around that. Even like to be able to get the circumference of the planet before the continental drifts and the whole landmass was one, and to get the circumference of 24,896 miles, which means that because when you look at, when you go back to the building blocks of life and atoms and so forth, you're really dealing with something we were taught by the master teacher, known as the science of the circle and the square, because you start to deal with geometry. So the circumference, from the circumference of being 24,896 miles, you can get the diameter. Cut the diameter in half, you get the radius, which will give you that middle point where the planet would have been centered. And that's where they put the pyramids originally, the right on the center of the middle. But then you start to calculate all the mathematics around them and how they align with, you know, the Orion star constellation, and how these beings that are saying they came from there to here, and this is why the alignment was made. And, you know, you start to deal with extraterrestrials, people start to say, you're crazy, you're cuckoo, and all this type of nonsense. But then, when you point out that in the Western world, the being that you call the most intelligent being, because they say, they call him God, Allah, Yahweh, whatever the name they want to give him, he apparently created this planet and everything in it, and he created day and night and everything. So that being, if you want to call him God or whatever, they use the word he as well, so he's got gender. He's male, and but he's an extraterrestrial because he's outside of our planet and outside of our solar system, etc. They use words like heaven, but what I'm basically saying then is that the building blocks of everything we see is from the circle, and then that circle, in the science of creation, as we're taught by the master teacher, was broken into half. So if you put a cross in the middle of a circle, you can turn it inside out and you get the square. You mentioned the cube earlier on, right? So now the square, which is known as a perfect square, because the oblong is also referred to as a square, but obviously it wasn't called that before. So you have a perfect square, but both of them have 490-degree angles, which is equals to 360 degrees, which is the exact as the circle. But you take a square and cut it in half diagonally, what do you get? You get a pyramid.
Yes, because you could get the 4-base pyramid, you could get the 3-base pyramid.
Exactly.
Oh my God, this is how you cut the thing.
Yes.
I forgot the name they give it now. Oh God, we used to do that. I used to teach my students that sort of thing. Not mapping. They've given it a they've given it a name.
Right.
I'll come up with it a bit later. But
just to finish on that point, so then you got the circle, turn inside out, gives you the square. The square cut diagonally in half gives you the. And now look at anything that you build. If you think of a house, you would take a square. The windows are squares as well, and the doors are oblong, and then the roof is a triangle. Now you can apply that to a car, to anything you see. You're literally seeing circles and squares.
It's the same thing with the earth.
There you go.
It's the same thing, that dividing. Oh my word, I never thought of it that way before. I'm going to come back onto that, but I've got a question I need to ask you about elements. If I took the proton from a hydrogen atom and I took the proton from a uranium atom and I swapped the protons over, would I still have hydrogen? Would I still have uranium?
Very interesting question.
Because they're not the same.
It's a combination, isn't it?
That's right, that does it, not the actual energy particles, as you said.
Yes.
It's the combination.
It's a combination.
Because a proton is a proton. No one says, oh, this is a nitrogen proton, so it can only work if I... No, that hydrogen proton could go in a helium.
Right.
In a helium atom. It's a proton.
Yeah. So even when we say hydrogen, what are we saying? Hydro is water.
Yeah.
You see, so the building blocks is the combination of the different elements that are producing what we would call different results, or like you were saying in terms of the metal or whatever, the density changes based on the more dense atoms that you're putting together.
That's right. And I wanted to just focus on the electromagnetic spectrum for a while, if I could.
Sure.
Because I understand that hydrogen is one of the first elements that we can actually detect. But can I just start from very low frequencies? We know that low frequencies around 20 hertz, 15 hertz, if amplified, the government tends to keep that off the record because it can vibrate your body parts, and your body parts be, you find your liver moving and things like that, and it can kill you. The further up you go, you begin to detect it, hear it. And if we keep increasing, we start coming into like these low radio frequencies and mid radio frequencies. Was still pretty cool up until then, until you start to get into what we call X-band frequencies, which is microwave frequencies. Now, this is a subject that I studied. And when they first put the mask up on the ships and that, the people that went close to it suffered badly, We now use them in our homes to heat our food, which is a much less power rated than the ones on the ships. So you can imagine it's the last thing there, and the beam is supposed to go over the ship, so anybody on the ship doesn't get the beam. But back in the day, they were climbing up, they were close to it, and it was cooking their bodies from the inside out, literally burning it from the inside out. What's interesting about the electromagnetic spectrum is that as you begin to push up and up and up, one thing I should say about microwave frequencies, it's got what we call an ionizing effect. Because if I use the old electron model, which I'm trying to get away from, it's causing energy to be transferred from one atom to another at that frequency. So it's getting dangerous. It's affecting the molecules in your skin. As you move up and up in frequency, this is what I find unusual. It's not affecting you anymore. Infrared, that's all right. Orange, yellow light. The most sensitive of the eye, yellow, it peaks there. Oh, wow, I could be exposed to sunlight all day. Obviously, the ultraviolet from it, as you begin to go up, that's because it's got ionizing effect. Again, we could use ultraviolet to just discharge things, electrically. And the wavelengths are so small. Have you ever been in one of these clubs back in the day when you walked in and you put on your nice clean jacket and everything, and under ultraviolet light, people, look at you, covered in dust, all your eyelashes, everything, dust everywhere, tiny particles.
Photons.
Yes, they could pick it up, right? Okay, let's just press on. Let's up by a few more micrometers. You start getting into X-rays. Now, down at X-band, which was microwave frequencies, it was dangerous for your body. We kept moving up. No longer does any danger seem to appear, because now it's to do with eye receptors. The rest of the molecules in the body is cool. Start pushing higher. X-rays, danger again, because now it's got a serious ionizing effect. And that thing is probably more deadly than even, the X-band frequencies, which is around about 30 gigahertz, 50 gigahertz, talk about 1-2 centimeter radar, that sort of thing. The frequency is so high, it can make the electrons leave the atoms in your molecules.
I was actually gonna, because you said a lot, and the electromagnetic spectrum, as you say, so you go from say gamma rays, right, all the way to what we're calling electricity, which is really low, and as you said, that's like between, obviously, the visible spectrum is between 400 to 700 nanometers.
It's tiny.
It's very tiny. The point about that is that there is so much outside of that we are being affected by, but we have no idea, because you can actually, with your development in terms of, the question I wanted to ask you was just going to touch on it, on the molecules in your body, right? Is that if you start looking at us as a bunch of atoms held together, like you were mentioning, your lungs, your liver and whatever, right? And even your face, why do you remain looking the same way that you're looking from day to day? Like, I will see you and still recognize, that's Neville, based on your face. But you're held together, your molecules, etc., etc., you're held together. Why doesn't it change every day? if you're just dealing with energy. Now, we're taught, again, by the master teacher, Panda Babylon, that it's because even though you've seen an atom, or let's say the planet rotating around the sun, there is the nutational rate is what keeps the divisions between the different states of energy vibration. You see, so that's why you're able to remain in the composition that you are, even when you're exposed to these different types
dangers.
of right, which will literally, because the G-force, for example, will pull you apart.
Will pull you apart.
Right. So this is where, again, he's teaching us things like it is each realm has a nutational rate, and each atom, even though we have the spinning, we have the nutational rate as well. So it's not just like it's not just rotating around us. If we use the planet, the Earth, rotating around the sun, it's rotated, but it's also spinning, and that spin is giving you a wobble, and that wobble is based on the nutational rate, and that would be different for other bodies and every thing as well. That's what maintains that structure.
So that's interesting. So as I push up past X-rays, which of course the frequencies are so tiny, it could just, on a photographic plate, it could just go through flesh. It would just go through flesh, but not ready quite yet to go through bone or tough structure. It will go through tough, soft tissue. And once again, if I should just mention the reason why they prefer ultrasound for scanning babies than X-rays. Obviously, if you want to kill the baby, I know, but there's something more than that. Right. Because the ultrasound, yes, they wipe it across and you can see the movement, all the rest of it. The X-ray frequencies are so fine. If that baby had a little wrinkle on its wrist, the X-ray would pick it up and show. You would see a baby like you're looking at a baby in real life.
Well, this is where AI is advancing to the point where now that's the type of technology they're moving to.
That's right. So you can see as it is. It's like with microwave frequencies when a radar system fires this high frequency, because the frequency is so high, the edge is sharp. So where the edge, it's the aircraft. It's not no 5 meter difference. It's exactly. They know precisely where the aircraft is, because the edge of the waveform is so sharp. When it gets back to the radar, it's precise. So these higher frequencies, it's got the purpose to bring crisp images. It's as I'm looking at you now virtually.
Right. Yeah, and this is where we're going with, and it's getting dangerous in the sense of what AI is able to do and going to be able to do in the future, which is distort reality even more, because going back to the magnetic spectrum and the visible light spectrum, is that when you're looking at something, like you said, is based on the photons and the light that is bouncing off of that object. And now with video created by AI, you're not going to be able to tell the difference from an AI generated person to a real person. It's just like if we take music, for example, where when we used to use more analog, it's like the analog was picking up a lot of information, but with the digitization of that frequency or those sound, the recording, the digitization got rid of all the noise to the point where your ears have been trained to hear everything so crisp and so clear, to the point where when sampling came in, when they were sampling a real, say, grand piano, and then you hear the digital version of, and this is why Yamaha and all these guys became popular, you couldn't tell the difference anymore. So when you look at sound, light, and of course images, we're doing that now, because when the internet first came out, one of the fears that people had was bandwidth, because bandwidth is really how much information you're able to, transfer from, say, one place to the other. And it was heavy in bandwidth because a lot of data was required when you were trying to send images and now video. But now with 5G and the bandwidth is really big now, it's like limitless. You can literally do what we were watching in Star Trek, which is completely digitize you and transport you or teleport you somewhere else, because every minute information about you, containing all your atoms and everything as it is in real time at that precise moment, can be digitized and transported or teleported somewhere else and reassembled, and you'll be back. So now, sorry, God.
The sort of method of doing that was highly discussed. And what they say is like, if you look at an MRI system, magnetic resonance imaging system, what it does, it takes slices of the body as you go under. I went under it once. They gave me this panic button. They said, look, because the claustrophobic effect and everything. Yeah. I'm just glad for the experience. I didn't hit the panic button, but boy, oh boy, you don't want these things. It's just like just over your head, and like you feel stuck in there, like you got your hand on the button. You're like, but I was cool about it. While it was slicing away at my body, they say, in order to capture that information, and this was on TV a couple of months ago, of one human body, enough to regenerate the human body in some other space and time. If it was done on CD disc, and you stack the CD disc, it would go from here to Mars.
Right.
The amount of information that for one person, in order to put it back again together. And there are other procedures that were put in place to stop them putting your head back on backwards. You understand? Because you had to be reconstructed as you were deconstructed. Right. You see, so yes, that they are thinking about it.
And this is what I'm saying, and I keep bringing back AI and things like that, because when you're looking at the Human Genome Project, that was to map all your the DNA strand and the amount of information that contains, because to be able to tell you the exact reaction or what will happen from, because you can rearrange the codes of the DNA in different ways. And this is why now they're able to literally tell everyone exactly who they are in terms of how they evolved, where they came from, based on the DNA. Yeah. But as you're saying, the amount of data, because even like you were saying about the slicing, because MRIs are allowed to check your brain and things like that. You know what I mean? But the neurons, the amount of neurons, in fact, dealing with like 24 trillion cells that, obviously fluctuates, that make up a human body. It's like, it's all about the data and how much data you can capture. Incidentally, another thing that comes to mind with the master teacher, when he wrote a book called A Man from Planet Risk, which that was in the early 90s, explaining about the Philadelphia experiment. I don't know if you've watched the movie.
I did hear about the Philadelphia experiment, and I'm sure I must have come. If you could just remind me again.
Well, anyway, it was an experiment by the USS Navy to try. It was an invisibility project where they were trying to basically teleport a ship, right? It was called a USS Eldridge, and at the time, many people worked on it, including people like Nikola Tesla and so on. But what they wanted to do is make the ship invisible and not detected over radar, but also teleport it from one place to the next. And this is a very well-known, it's a real experiment, but they've made it into a movie. But what happened is that during the experiment, people that were on board the ship, they went back in time. They got thrown into I think it was 1984, and others got kind of like mangled with the ship, but there were two main characters, Belek, and I can't remember the other guy's name, but one of them didn't make it. But this relates to our conversation because it was about taking such a massive object, breaking it down and transporting it from one place to the other. The experiment went wrong because at the time they didn't have the right computers or enough technology. And I think what was explained is that Nikola Tesla was aware of this, and he tried to stop the experiment happening and kind of sabotage it. And they had to wait till later on when they had enough computer power. And what happened is that because of that, the master's teaching taught us the reason they weren't able to be successful with the experiment is because in order to do that, each person has something known as a zero time reference. Yeah, that zero time reference is the information that is required if you're going to carry out these types of calculations in terms of teleportation and knowing and mapping who you are. Is that zero time reference is so vital in the calculations, and the zero time reference is the moment of your conception in the sense of when the sperm hits the ovum, that particular precise moment, that's what makes everyone unique. But obviously there's a lot of other calculations or information that is required to be able to do that. But these are the types of information that an extraterrestrial or someone who knows about supreme mathematics or mathematics that is beyond what we're taught. And some people say it's actually a sinister objective to maim people and reduce us from knowing, information that will help us as humanity to evolve and move on to things like interstellar travel. This is why I was interested in what Terence was saying, that you can't be using the type of fuel that we're accustomed to now. Like, do you know what I mean? You got to have, and again, we were taught about, what is it called? There's a technology that the extraterrestrial crafts use. It'll come back to me, but it was something that even people that were working on crafts that have crashed here, like in the Roswell and stuff like that, they were trying to re-engineer, these types of technology. It's just escaped me now, but it may come back to me later on. But so yeah, what we're basically saying is information or data is so important. We're now in a day and time with AI, where AI can actually provide that level of sophistication because AI is literally able to absorb and learn all the information on the planet in seconds, and not only learn it, but able to, predictive programming, put everything together, and things like that are going to be very possible.
No doubt, what you say there rings a bell with me because I can only sort of grasp at how they may dismantle a body, how they would go about. They've read it, they've got your code, but when they reassemble you, it must be as exactly as they left you. The method of disembarkment into another form, that channel, because if they could get that far, then I just think time is unrelated, because they could have you for the next 1,000 years, and when they bring you back, only half a second had gone.
Exactly.
In your lifetime. Once you're in that form, time may not be relevant anymore. You know, as I said, spend 1,000 years in your disembarked form.
Well, we saw this in many movies, like, what's that one with, he came back from the future?
Is it that guy with the car? Back in the day, Back to the Future?
No, not Back to the Future. It was, I can't remember, Drake or Blake, I think. Blake, something like that. But basically it was, he got frozen because cryogenics, basically. He was frozen in time, and when he came back to Earth, it was like many light years or some years had passed, but he was still the same way he was when he left.
Yeah.
And
Yeah.
but we know this because even in the religious books, they tell you like people like Gabriel or people that time travel between what we consider the Old Testament, which will be thousands of years ago, to still appear in the period of what we're calling the New Testament, which will be 2,000 years ago. So the ability, even NASA, people that go up into space, they come back and they haven't aged, or they're younger, in fact.
Well, there's one woman, she visibly aged when she went up there. She came back with like grey hair.
Right.
Whatever. And it's to do with the way that the craft is rotating the Earth. But I just wanted to touch on a point before I forget it.
Sure.
And I'm going to ask you a question here. What do you know about element 115?
Well, okay, so when you look at the elements, there were many elements. Again, this is something that the master teacher wrote about years ago. Do you know what it's called? Is it Omnicron?
God, I've just heard the fact that they've probably made 4 copies of it,
right,
and the fact that it's got anti-gravity.
Right. This is what I was trying to say about the re-engineering of things with like Bob Lazar and people in Area 51.
Yeah.
It's because when you start to deal with extraterrestrials and you deal with, their crafts and their technologies, and these are the things that come up because some of the material they find from these crafts, they try to re-engineer. But the point I was making is that the master wrote about a lot of the elements that were not discovered yet before they were, and he told us about them, and he said they're going to discover them. So by the time, obviously, they did, this is one of the unique things why we say he's an extraterrestrial from our future, and he's a visitor here. And if someone is a visitor, they're going to have information that is not going to be, do you know what I mean, like in the mainstream, so to speak. And but we're still learning, and unfortunately, because of his incarceration and the kind of mainstream trying not to make him known to the world and to people, he's not able to provide solutions and help in many ways, as well as give us information to, make sure if someone says they're an extraterrestrial and they have all this like technology and more information to help us advance, why would people not want to make that person known or available to the world? So these are things we're fighting for, because it's for the development and the advancement of us all. We need to know things that will help us, and unfortunately there are those who they benefit from being the ones who have certain information they can capitalize from.
That's right.
And hiding it and not telling you, and distorting things. Because even like when they have all these wars that are going on, a lot of that destroys evidence. Because these ancient peoples that you might look as primitive, they've got recordings and writings and things they were doing back then that scientists are only kind of like embarking on now. So if they had that type of information and technology back then, how far do you think they are today?
Yeah, that's right.
So this is why the extraterrestrial, or they say aliens, is such an important topic, because we're learning about these beings that were so much more advanced than we are today, and there are people who have access to this information in libraries and hidden that we need, and it's going to be exposed because we're living in that day of time. We either evolve or we're just going to stay stagnant, or even worse, regress.
Well, what's interesting is that on the periodic table, when I was at school, and I never studied chemistry. It's one of the things I never studied. Somehow I ended up teaching it, but what I discovered at the time, there were gaps in the periodic table.
Right.
And I used to say, well, what's the gaps for? And people say back to me, we know the element exists, we just haven't found it yet.
Right.
Because, everything seems to go up in order. So, why should you jump 5 ahead?
I used to say exactly that myself as well.
Where's 3, 4, and 5?
Yeah.
Where's 3 and 4? If you've gone between 1 and 5,
Yeah.
So it was obvious they were going to find these other elements.
But it's an interesting question you're posing in terms of, I'm pulling up the periodic table now. It's interesting that, but that's another thing, that people challenge this version of the periodic table that most people are familiar with, you see.
Yeah.
So, I'm just trying to see if they've got it on here. But it's a very interesting, I used to think that, but as I said, it's because they can tell where, if you find something and you break it down and the composition of it is made up of, let's say, like you were doing before, however many protons and however many atoms, and then you find another one that has the same, or maybe something more, then you can kind of deduce that there's something in the middle between that one and this one. So that's kind of how they get the gaps.
Yeah, and I just want to sort of shift into the realms of the nuclear side of things with the particles right now, if I could.
Yeah, sure.
So they found these elements, and I believe how is it arranged? Is it that the more reactive particles are on the left-hand side of the periodic table and the noble ones on the right? I can't remember exactly where it was. I never really studied chemistry.
Here it is. It's like...
is it noble on the right? Or
the nobles on the right,
Yeah.
So
all right. So. That's right. And the reactive ones are on the left.
Yeah. But
there it is. Magnesium, radon. Oh, my God, yeah. They're on the left. And on the right, you should have argon, aluminium... that sort of stuff.
Right.
Okay. Basically, the concept of whether these are physical particles or energy particles makes it very kind of like difficult for me to draw the line between the experiments and all the how can I say, examples I've shown my students, and being torn between what it really is. Because as an electronic engineering lecturer, I've had to manipulate certain experiments in front of my students, giving them the usual rhetoric. Now, if a neutron is said to go into let's say another atom, dislodge its neutron, which goes into another atom, and dislodge it. So it's going 1, it may go 2, 4, 8, 16. Before you know it, the whole thing's gone. If that was in energy form, and not because they showed to FIS, the neutron goes crashing into another atom. If it were pure energy, then we like to think the energy just impinges on it. And you don't think about like energy go crashing into something, do you? Does it just, or is it already there? Because nobody's gone down to that level. They're all mathematical models that work.
Right.
No one's ever seen it.
Yeah, modeling is one thing to the reality, and there are gaps, and there are going to be things that Western scientists do not know, and when it's okay not to know, but it's one thing to not say you don't know and you're still looking. And then it's another thing when somebody comes along who says, I do know, and you don't want to listen to them to hear whether or not what they're saying is true or not true. This is the dilemma we find ourselves with our master teacher. But if you remember what I said, because you started off saying, how do you know, when you're teaching the students, is it physical or is it not physical? This is where quantum mechanics comes in, because things only appear to be physical because they are actually clusters of energy. But the difference is the density of that cluster of energy. So as you speed up, you're going that way, the vibration gets faster, but at the same time, the density level it's less than when it's coming this way. So, but the thing is, when you go this way and that way, you're stuck with the situation where, okay, how far this way do you go before you end up on this side?
Yeah.
And if you go this way, how far do you go? So what you're finding is you're basically ending up with a cycle or a circle, right? Because things can go from very cold to so cold that they're hot because you can get burnt.
Yes.
Right? And the same way, the other way. So if you were saying this is hot, you're going to go so hot that it's going to get cold as when you go into space. And so what you're finding is when you start to look at, say, black holes, for example, what you're really doing is going, okay, everything gets sucked into a black hole, as they say, and doesn't come back out. Well, where does it go? It comes out somewhere else because there has to be an equal balance, action and reaction, right? So what we're literally doing is spinning, but every time you spin, you're not starting again at the same point. So it's a constant, like if you look at what they call singularity. So if you start from a single dot here and you're spinning, it's like a cyclops, isn't it? Or a whirlpool, which is doing that, but it's expanding, right? So when it expands to the point where it can't expand anymore, then what does it do? Collapses. So you got a thing where if you were looking at the pyramid, you would have, let's say we laid it like that, you have that side, then you have that one going like that. And if you look at the point in the middle, you're literally looking at what you call a black hole. So there's always going to be that going from hot to cold, or from day to night, as we call it, or from, white to black and black. So there's a constant cycle happening, and that relates to how everything is cycling in terms of the different forms of energy, even where you're saying hydrogen is what was the first element. Now we know it wasn't, because when you break down, subdivide hydrogen going in that direction, you're going to start to get to ether, E1, E2, E3. These are the levels of gases where they come to, say, noble gases, and then it goes down this way to form a lot of the more dense physical elements.
And that's what I'm waiting for to see in the near future. These elements that were so-called invisible to us, because I know, because, hydrogen seems to naturally be the first. Why? Because of one proton and one electron. But there are others before that we can't detect. And who has access to that kind of knowledge? Because
this is where technology comes in, because if you use your eyes, they're telling you you're limited to the visible spectrum. But if you use a camera, which is, digitally and mathematically put together to, let's say, see beyond the visible spectrum, because all you're doing is you're taking pictures, as you said. Even when we were talking about the slices, how thin do you have to slice let's say the brain to get every piece of the information?
This is another thing
together. You see, so this is what I'm saying. AI is. And AI, again, is alien technology, extraterrestrial technology.
There's a point I want to sort of touch on to. And once again, I have to mention Mr. Howard's name, because he said that Kirchhoff had his laws were incorrect. They were wrong. Now, once again, I'm a pragmatist. And I have to teach my students Kirchhoff laws. And it seems to solve the problems, and we could do mesh analysis and all the rest of it, but it works with what we do. For instance, if I have two wires coming into a point and three wires coming out from that point, and remember, every wire is identical. Say I have 6 volts and 6 amps and 7 amps coming in on the two wires, so that should make about, or I want 12. So let's say I use 7 and 5. 7 amps and 5. then I know if I've got 3 lines coming out, exactly, each one's going to have 4 amps on it. Now, am I correct in saying that the input is equal to the output?
It's supposed to be.
Right, okay then. All right then. Let's work with supposed to be.
Right.
Yeah? So I've got 12 coming in and I've got 12 coming out. I'm going to go on to a 2-dimensional mathematics paper. And I'm going to say 6, or what was it, 7 plus 5,
5, 12.
is equal to 4 plus 4 plus 4. Now, nobody's going to force me to do this, but I'm going to say, well, if those two are equal,
Excuse me. Yeah.
I can add them.
Yeah.
And in order to add them, I've got to bring the quantity on the right-hand side of the equal sign over to the left-hand side of the equation. And when I get, what was it again? When I get 7 plus 5
yeah.
minus 4 plus 4 plus 4, I get 0. Now, this is what's interesting, because you've got 12 coming in and you've got 12 going out, 4 plus 4 plus 4. At the middle, there can be no current. Now, that's what that equation is saying. 12 minus 12 is equal to 0. What's the proof? Well, in electrical engineering, we are fed via a star network. We have 3 coils arranged in star fashion, and the voltage across each coil is 230 volts. Guess where the neutral is? The neutral is the center point. The only way we could use the neutral as a center point is if there is no potential there. Because as Terence was saying,
This was his argument, like you can't destroy energy.
You can't destroy.
Have to equal.
It's actually, what did Terence say? It's seeking, it's centripetal. It's using the centripetal force. It's always spiraling down. It's always going. You see, electricity can't just stay there. It shows its head momentarily. It's got to go to Earth. It's like, God forgive me, it's like Dracula coming out, no, I'm going back to the dark. Electricity will come out.
But this is it. It's centrifugal and centripetal forces, because there's got to be a pulling.
It's got to be a pulling force.
That you have to have the two, like contraction.
That's right.
Yeah.
So someone would think that, you've got 12 flowing, that center point there, but it's given it to the 3. Mathematically, it's saying that at that point, there is no potential. In the star network, here where we get our 230 volts from, the neutral is fed back into the center of the star because there's nothing there. So that's the return path. You wouldn't use it as the return path if there's potential there. It's called a virtual Earth. It's not the kind of Earth where you'd knock a copper pipe into the ground to stop radiation getting to it, and you put
that's the whole thing Terence was saying. Again, this is not about Terence, but it's like, if you're using the mathematics to carry out the models, then the maths has to make sense, because you can't get it even a minute wrong. Because if you're dealing with interstellar traveling, or when we're talking about warp speed, or you're dealing with, things where you're going from one place to the other and you're traveling at that type of speed, beyond, say, the speed of light, or the speed of light even, you can't miss your trajectory by even a 0.0001 accuracy, because you could go straight wham into something, right? So the math has to be so accurate. Now, for our viewers, because we might as well be speaking Klingon.
Yeah, I know. Because
to some people, this is where you have what we call the 3-dimensional world that we live in, which is, you have, like you say, you got this side and that side, and we go to computers and binary, make it easier for people to understand. You have a 0 and you have a 0 and you have a 1, right? And people will say that's Boolean, right? Or on or off, or yes or no, or whatever. But before you can choose whether it's a yes or a no, or a 1 or a 0, you're in the neutral state, in the middle state. So that's why we have these 3 states. And once again, it's no coincidence that these 3 states, 0 here, 1 here, and then the middle if you take that middle and go upwards, you're going to get a point there, you're going to have a point there, you're going to have a point there, you're going to get the pyramid again. Now you stack a pyramid on top of another one, going the other way, right? So you get the diamond shape, which is again a square if you look at it like that. So this is what we're talking about when we're saying supreme mathematics and dealing with, and if you keep stacking those pyramids, like top as above, so below, as above, so below, what you will start to see is that double helix that is going to be built on top. And Terence shows this when he puts his models together, but not with straight lines, but he uses curved lines because as he explains, things in the universe are circular, they're curved, they're not straight lines, which makes perfect sense.
I'd just like to just add something there just to prove that point about the curved lines. They used to have this navigational system called the Loran system back in the 80s, navigate ships all over the world. Do you know what they did? They had these transmitting beacons at certain points on the globe.
Right.
These would transmit a wave. So, you know, the waves would go out circular from the point and would intersect with another mask. Where they intersected, it formed parabolic lines. They were curved lines. And each one was given a certain frequency.
Right.
So if I was in the Atlantic Ocean, let's say, and I wanted to get back to, I was heading towards America, and I wanted to get back to Finland or something like that, let's say, I would go on a certain frequency and it would be placed on a globe. And that frequency, you follow the line, it will take you right round to Finland, so long as you stay on that frequency.
Yeah.
So this concept of curved lines, when waveforms interact, is very much alive with what he's actually
It's in
saying.
nature, you can see it. The rainbow is what you've just described with the different frequencies and different colors.
Yeah.
So,
They form the opposite reactions to the reactions is to form curved lines.
Yeah, so
It's,
again,
you know,
I like the example he gave in terms of when you look at even, you know, nature, the way if you cut trees, if you just look at things, just they form the Fibonacci kind of, you know, you look at the maths and that, it all ties in again. So it's like, would you rather have a female companion that was made up of straight lines or curved?
Or would you like a curved one? I prefer the curved one.
Very interesting. You know. But again, bringing it back to Wu-Sabat, this is why we are not constrained by, you know, what the mainstream will say things are, or that, you know, this is the curriculum and these are the scientists, and because they say so, we go along with it, because we have a culture, we have scientists that predate what we're being taught in the Western world. And like, not just us, but you can go to, like we said, the Dogon and different tribes around the world who for years were teaching and saying things are like this, that people argued with, until later on when they had the technology and, you know, the satellites and everything to map exactly what the Dogons were saying.
What we're saying all along.
A, B, and C and things like that. So we know we have amongst us one who is teaching us, and this is the new information. This is why we have to teach the information that we're being taught by our ancestors, regardless of whether or not, you know, people want to accept it or not. But in time, as everything else, the master teacher has been teaching us over time becomes, you know, it becomes something that everyone jumps on, like the extraterrestrials and all of that kind of stuff.
Becomes folklore to us, you know. It's like, because people need to start realizing that these things are going on around them, and like with every day, and some of these programs I look at, and some of these testimonies that people, like out in the Nevada, places like that, you don't walk at night on your own because you know what you're going to walk into. They talk about this and these beasts that exist. The man should get scratch up on his hands and all them things walking through those places.
I mean, the science, mathematics, and the reality that we're living in today is that we're going to get a lot of things that are going to be made clear and revealed to everyone, to the average person. But of course, there are people who, just like in olden times, if you said the world was was flat, they'll accept it. You said the world is round, you know, you might get put on a stake, you know, like. But in time, with the right information, right tools, even now, like we're saying, the James Webb telescope that is able to now look into space and look into the birth of the universe, you know what I mean? It's like, we're gonna get more. That's why I was saying about, you know, you're not dealing with your eyes, which are limited to a specific spectrum, when you can use the mathematics to build eyes, which we call telescopes or cameras, that can look further and deeper, and not having to worry about, you know, if the ultraviolet rays or whatever might damage my eyes if I look, you know, into the sun.
One of the things I like to mention here is, how far does the spectrum go? We stop at gamma. And that was it. There's nothing beyond that, you know. And they say, "Oh, cosmic rays." What's that? You know what I mean?
They don't know. that's the reality.
Do you know what I mean?
Yeah.
Because what is up at the upper end of the electromagnetic spectrum that can be seen, that is being manipulated, and when the frequencies are so small, and if they make drones or whatever, are we surprised that physical objects can walk through physical objects and see? When you have that kind of experience, when you know about these things that are so tiny, these waveforms, they could penetrate anything. And
I watched something that was should be quite scary, that I'm not going to mention, but it was on social media, where someone, a whistleblower, was explaining that the American government has technology where, because there was a discussion about planes that have disappeared, you know, that just disappeared, and people were saying, like, obviously there's an extraterrestrial element to it, where these objects can be literally taken away from the sky or taken into other dimensions or whatever, so they just go missing. But there was also someone, a whistleblower, saying that they have technology now where they can literally do that, take a plane away from the sky and take it to wherever they want to take it to, or even just get rid of it and it will just disappear. Like, this is the types of things that, you know, people are saying. There's technology that is already available, because, you know, things are classified that, you know, you won't know, but certain you know, people that work for these, like, you know, I mean, that work on this project, and, you know, military or whatever, they get to work on some of these projects, and they know.
The reason why I believe that this is very possible is because there are people who can say, if there's an entity in this room now, on what frequency is that entity vibrating? The reason why we can't liaise with that and we can't feel it, we can't touch it or anything like that, is because those frequencies that we cannot see, those frequencies, or even those low frequencies, those that are well outside of our detection, not even our eyes, our equipment can't see it. These things are being used, and it's beyond the visible range, and it's probably beyond the range of touch.
Well, again, in Wu-Sabat, we teach and know that, because we know you can't destroy energy, and we know that your ancestors, they're just on those vibrations, on those frequencies that you're talking about. And if given the right situation and circumstances, you can actually literally communicate and manifest them.
Yeah.
So people do see what they term ghosts and, you know, disembodied entities and, you know, all kinds of stuff. So it's definitely showing you that there are entities that are existing in different dimensions. Yeah. Because one of the things, again, that I think is a distortion in science that we were taught is, like, two things cannot occupy the same space. But we know that that's not actually true, because you can. It's just that you're on different vibrations or different.
But are you in the same space though? If you are,
Well, this is what you call in space.
You know, because if you think about it,
I can answer that very simply.
yeah.
You sitting there right now are composing more than your physical body, but you're in the same space, which people may call your spirit, your soul, which is not tangible to you, but even what people call like your mind. So that is occupying the same space. We can go to the breakdown of your physical composition and say you're made up of tissue, as you said before. You're made up of blood, white blood cell, red blood cells. You're made up of the plasmatic you. You're made up of electricity because you have, your brain is sending electricity around your body, the nervous system, the skeletal system. You've got so many systems that are all within that one space that you're calling your you.
Yeah.
So you can be in the same space, but different parts of you in different density levels or vibrations.
Yeah. The key words that I pick out of what you say to me is density and vibration. Because this thing, density as well, it's like it's like another set of storage cupboards where we can put stuff in. You know, the different densities. You've got different vibrations. Wow. So that vibration could go with that density, or that density go with that density, rather than just vibration or just it opens up the scope a bit more for more things to be apparently existing on some kind of plane because of it.
Right, exactly.
This is the density that this is it's heavy, it's highly dense. You can be in that plane. You're less dense. You could be another plane.
You can just go underwater. And that will explain.
It really is amazing. Because the fact that you mentioned water again, I wanted to ask you something on water again.
Go on.
And they say that, beryllium can separate hydrogen from oxygen, right? Now, is it that the beryllium takes to the hydrogen, does it? Or does it take to the oxygen? I can't remember which one it does. But water can be broken down, but in its normal form, it will not be denied. Anything goes crashing into water, you're going to have to obey by the laws of water.
Right.
And water might as well be as tough as a table, depends how you're going to hit it, But this thing, the molecules actually flow over one another. And that's why water is what we call fluid. Anything, the physical example of that is an avalanche. If you get an avalanche, you're seeing a solid behave just like water does.
But water transforms from solid, liquid to gas.
And this is one of the things I wanted to ask you, I'm coming on to, the states of the solid. We go solid, liquid, gas.
That's for simplicity again. This is why, that's what I was saying about modeling and science and putting things into a comprehensible way that people can visualize and make it simple for them to get.
Yes, that's right.
But really, it's not that simple. Nothing that is simple is actually simple.
Well, what I'm about to ask you now is not simple.
Right.
Because you go into the steam, which is something that burnt me years ago on my wrist there. That will never disappear.
Right.
Got my hand too close to the kettle. It came up in a big... the fluid had to be pulled out by an injection. That is the plasmatic state of matter. What's above that?
Ether.
How does it...
This is what I'm saying, this is why ether is going to keep coming up. And we are teaching it as 9 ether beings because ether is the most powerful thing you can consider or think about because it's the combination of all existing gases and conscious and conscious gases. It's a combination of all of them in that form, which means it's able to metamorphosize into anything, right? This is why you were talking about how things are combined to become what they are.
Yeah.
It's like hydrogen. Hydrogen is actually in everything, even though you may not think of it like that, because when we're saying hydro, because we're really using water, but in a different state. So we're saying taking water, which can be very fluid and very calm and beautiful for, we wash with it and we drink it, etc., to becoming a tsunami or to becoming an avalanche, which can then destroy and completely, eradicate anything in its way. So water is a great example to show what we're saying we are, in the sense that it goes from solid as ice, but that ice, if you were to break it down, there's so much variation, right? So we go from ice to the liquid, as we call it, the fluid part, to steam. But then that steam can continue to go onto other states, which we may not see because it vaporizes, right?
Yeah.
And we say it's disappeared.
Yeah.
But it's just continually transforming into the other states, which we go into what we call ether.
Yeah.
So water is always returning back to itself, like in that cycle. So just like how when you look at colors, I gave a bit of an example with the rainbow, where you say, you look at or even just like the primary colors, where you have, is it red, blue, and green?
Yeah.
Where you then have to mix them to get other colors, but each one of those is not just a red or blue or green. It's like I say millions, but you can. It's infinite amounts of variation of that color. It's the same when you look at the solid in terms of the ice. There's a variation that's of what you're calling that state.
Yeah.
As there is a variation of what you're calling the liquid.
Yeah.
As there is a variation of what you're calling the gas or the, the steam, which then goes into variations of ether at various levels.
Yeah, because when you talk about ether, the only element or not even element, but the only compound on Earth is not just water. There's us.
Exactly.
We are solid. We can become liquid. We can become gas. We can become ionic.
Yep.
And we can become ether.
We are all of those.
Yeah. So, when you get above the ionic state of matter, you've got to start thinking about everything.
Absolutely. That's why ether is a combination of everything, and not everyone has ether as well. Just like I said, everything has hydrogen, or even melanin. But the thing is, different. I have to keep coming back to the word density again, because different people. If we start to look at race, because even with races, people are trying to find out. People say things like, "Oh, we're all one human race." There's only one human race, but then when you start to look at the different races, the root races anyway, there's no doubt that things come from things that come from things that come from things. This is in everything, including race. So as the Africans, the anthropologists will say the Homo naledi or the Homo habilis, that's where others come from, or the components that make us up are used to make everything else that comes afterwards. And then you get to a stage where you're just using genetics, we say GMO, genetically modified organisms, right, to come up with something which might look like the original, but it's artificial.
That's right.
Because you're just arranging the different molecules and
but it's
atoms.
all stemming from an originator, isn't it?
Right. But the thing is, you're losing. This is what we were saying, that when you said, is it always going to be the equal amounts? No, because you're losing something as you water it down, and as you make it into a, what I would call artificial than the original.
Than the original.
Yeah. So you can have a banana that you grow, and it's got, the way a banana will grow naturally. And you can have a banana that looks like a banana because you've been told that's a banana,
Yeah.
and because your visuals or your visible spectrum has been given an image that you've stored, that looks like a banana. So you see a banana that's like massive, that's not an original banana.
That's right. It's not,
But now if you grow up and you've been taught from a child that that is a banana,
Yeah.
that's a banana to you.
Yeah.
You see, so but the nutritional value that you get from that genetically modified one is not going to be the same as the original. And it's the same with us as people. And this is why we face things like racism, and we face all these I don't even know what to call it other than jealousies.
Well, negative.
Because,
of course it is. All these
because
negative reactions and everything
you're
else,
saying,
right,
you know more, or you came from a stage where this information was available to you, and now you're returning back to that state. And this is what we're doing. We're transforming. Because as you say, like water, we are evolving and we are transforming.
That's right.
Our minds, our brains, everything is changing.
It's just that I'd like to see the curriculum, the teaching curriculum, and some of the data that they've logged. Because I know there's certain things against like what we say about historical events and what they still hold as historical events. But when it comes to technology, some of these ancient methods they use needs to be updated.
They do.
Very quickly, because number one, we're supposed to know that there is no such thing that's called free space. It doesn't exist. We were never granted that. No, if you look at the steam train, you got a tube back in the day, the steam train, you pump steam into it, it lowers the air pressure, so it's gone. What happens? 8 tons of air pressure pushes the piston down. What's the piston connected to?
That's right.
Rods that turn the wheel. And you let the valve out, air fills up again and pushes back. But
combustion.
But really, was it a vacuum that the steam sucked out? I mean, it doesn't matter so long as it pushed the piston down. But, once again, nothing can be created from nothing.
But this is the problem. It's English. Because when you say nothing, people automatically, in their mind, think of space, empty space. But empty space is not nothing.
Right.
Because when you're saying nothing, what you're saying is no thing. N-O-T-H-I-N-G, no thing.
No thing.
What then you have to break down what is a thing. A thing before now was something that they can measure and say, okay, hydrogen is a thing, helium is a thing, and this thing is composed of, as you said, one atom, right?
Yeah.
So now we're like, okay, what we were calling no thing or something that was not quantifiable is not quantifiable, because we now have technology that what we thought didn't exist actually exists. It's just that we couldn't measure it.
Couldn't measure.
But now we can measure it. But then there's still things, even though we can now measure, biaps, quarks, zeelies, there's more that we haven't encountered that is there, but we're now saying nothing exists beyond this point. But we said that before with hydrogen. So if we got to a point where we actually came to realize that actually there's more stuff. So it's not no thing. This is nothing until you discover it.
Yeah.
Until you quantify it to say now it's a thing. Yeah. Then we say, okay, that's something. The sum of a thing, S-U-M-T-H-I-N-G.
Yeah.
But we say something, S-O-M-E-T-H-I-N-G.
That's right.
But we're literally saying the sum of a thing.
The sum of a thing.
Yeah.
That's what
that's the only way people can accept that something exists if you can prove it.
You see,
so that's what we go by in science, of proving and quantifying and providing the facts to back up what we're saying.
And the reason why they tend to stick by that is because they get relative measurements off of it. Look, they need a reference. And by Joe, they're going to get that reference, one way or another.
Yeah.
And if they manage to measure in a vacuum that they can detect that magnetism could be developed, and they could detect that electric fields could be developed. What we're going to do, we're going to say, with regards to magnetism, how good is wood at being magnetized? Well, we know it's really useless at developing a magnetic field. Let's call that 1, or around about 1. And that way, we can use certain other metals, or what do you call it, as not so much substances, other kind of like if we went from wood to brass, bronze, ferromagnetic material, other materials, until we got to iron, which would be about 200,000. So wood is 1, iron is 200,000, which means that it's very good at inducing a magnetic field, which means mu naught, which is the permeability of free space, was useful to us because we could grade the ability of other materials to develop a magnetic field. However, if they came to the conclusion and said, look, we know nothing doesn't exist, the calculations are completely thrown out.
This goes back to your Terence 1 + 1 thing. But the thing is, why use a vacuum? Why would they conduct experiments starting off with having to have a vacuum?
If they came to the realization that at some stage they would have to confront this that they've got away with for so long. Because it works. It's pragmatic.
That's right. We do things because it's always been done like this. And that's not acceptable in today's day and time.
At today's standards.
Yeah, because, I mean, we get why, because you conduct experiments in a controlled environment in order to be able to get give the outcome. But the thing is, that's what we're saying when we're saying what you're calling a vacuum is the ultimate vacuum is going to be ether, because that's where even the speed of light is within that vacuum, why it can't escape it. You see, so we're in a different day and time with Wu-Sabat and 9 ether knowledge and 9 mind, that we're not under the constraints of the Western world or Western scientists or like information that has been used and just accepted for years as being, the way to do things.
That's
we have
right.
to look at.
They're going to be pulled up. They're going to be pulled up about it. And hats off. It worked, and I was able to, do what I needed to do based off of that so-called rhetoric. But now you're going to have to change the narrative. Yeah. Because the narrative says that
you're not gonna progress.
We cannot progress if we don't acknowledge that phenomena that's right. in there. Yeah. There is no such thing, and I'll say it now, there is no such thing as a perfect vacuum.
No.
It cannot exist. You cannot have something with nothing in it. To get our heads around the concept of nothing is like, talk about deep, dark space, whatever. Ether will always be there.
Absolutely, 100%.
They talk about, the cosmos or cosmic rays. What do you think? You're trying to tell us that there is something?
Models.
You're telling us basically that there's something in space and you don't know how to describe it. But you just know that it's there.
That's
and
right.
when you go to measure things, lo and behold, how did it have the ability to do that? How did it have the ability to do that?
Yeah.
Nothing can't do it. Exactly. Come up front. Be straight.
They gotta be honest. And if we don't, then how do you move forward with?
You cannot move forward.
Old knowledge and old information. That's why we're here. Right knowledge, right wisdom, right understanding, which is not just based on the basic questions that people ask. It's like Wu-Sabat has always, from the beginning, dealt with scientific information. Like I love having conversations with you because we're not stuck on Jesus and Muhammad and Jesus and like just like these books that are so like easily debunked. Do you know, we have to remember that Wu-Sabat deals with actual facts, and that will cover every subject matter. So these conversations for me are so much more fulfilling, because it's like you trying to tell someone that it's in a belief system and believe something, and you say, okay, prove it to me scientifically, and then it's all of a sudden that they don't want to address that. But how can you tell me that someone or something exists in a place that you've called heaven, and that they have these attributes of being jealous, being angry, sitting down, destroying things, etc., etc. But if I just say, okay, let's just deal with the basic. Where is this place? Where, like, can we measure it? Can we go there? Has somebody been there? How can you tell me this place exists if you don't have any information? Even when you point it out that it was just misinformation or mistranslations, where the place is actually got a name. They're telling you it's an actual constellation. It's a place, Pleiades. You can look it up in the star maps, you know. You can look at Taurus, you can look at Orion, you can look at Sirius now. But yet, you want to make it like it's some fictional place that doesn't exist, when we know factually there is a place called Orion.
And this is the thing, you know, as I said, Wu-Sabat is the backstop. You don't go beyond Wu-Sabat. And you know, you take all the other religion, take what people, whatever faith, even the Hebrew faith, what they've got in America, everything like that. Because you guys, when you guys tell people things, you're reading from the scrolls. You're reading from the rocks, the carvings, the everything that was written down, the hieroglyphs, everything. You are taking it from that.
That's
you are saying to the people, this is what has been recorded. And there's something else that Wu-Sabat sort of came up with as well. They said the bodies of the disciples of Jesus have never been found.
They haven't.
But yet they find every king in Egypt and everything. And when Jesus went there at the age of 12 to study, everything, what he must have learned. Of course, when Pharaoh hit the rod, it turned into the snake. All these things, you got to start with the knowledge that you've been teaching people. And that's why I have to bow to you people. And I don't care if I do it here and anybody says, oh, blah, blah, this and that, or I got preferences and that. Do what Wu-Sabat is doing if you need to get onto that level. Reveal the things that are being held back. It's not just the events that have taken, I was going to say religion, but I was careful not to say religion. Events that have taken place on the earth. It affects sciences.
That's right.
It affects people's well-being. It affects everything. All the quantities of society that you see these governments put down and have all these different offices to deal with, Wu-Sabat do with all those things. Coming from a perspective that really shows you why it needs to be done that way. It's like it covers everything. It's just amazing what Wu-Sabat do.
Because it's for humanity. It's like truth is truth. And this is what I was saying at the beginning, that we're living in a day and time where if somebody really does want to know, because if you want to grow, if you want your mind to expand, you have to learn new things. It's just like saying, you know, what they call the dark ages. You're stuck in the dark ages. You're stuck in the time where we didn't know certain information, so we weren't able to live longer. We weren't able to do certain things that we can do now. Whereas Wu-Sabat is just like, research it, check it out for yourself, provide the evidence, because the evidence will ultimately. But don't hide the evidence, or don't make us think, oh, there is evidence, but we can't show it to you, because that's not the scientific method. No. The scientific method is to prove what you're saying, and we put ourselves in the firing line to answer questions, and we want to be able to do that to everyone. Don't just, because you see, the thing is, believing something is fine. Nobody says there's anything wrong with you believing something. But when you believe something and then you try to subject other people to your belief just because you believe it, and those people are more advanced or more like I want to know, because to know and have knowledge is going to always win over just believing because somebody has an opinion and because they say so. So this is what Wu-Sabat does. Wu-Sabat deals with, okay, you're claiming this, but let's scrutinize it. Let's ask you some questions and let's get to the bottom of it to see if it makes sense. And if it doesn't make sense, then you can carry on believing it. But we're not going to be, in the day and time we are, with all the technology and the knowledge we know, get into divisions and arguments and wanting to be right just for the sake of wanting to be right.
Just for the sake of being right.
Yeah.
Because I'm wrong. I'm right and you're wrong.
Yeah.
Just for the sake of that, instead of listening to it. I mean, I've listened to you like speak to certain like Christian woman that would not accept. In the end of, you're there with the board and you say, hold on, lady, look, just let me just show you. No, I saw Jesus in my sleep. I saw him. I remember, and this and that. And they have it in their heads. And they are forgetting what dreams are or what it can do according to what's in your head.
Exactly.
And it's has made it that it's real and that everything. And from what I understand from the scriptures that were written, Jesus said, do as he did, don't worship him. He said these fathers up in them. Why? But you got these people, oh Jesus, to
Yeah, because it's always easier to pass the responsibility on to someone else. You don't have to do any work. You don't have to be. Yeah, just let him deal with all the problems, and you just wait to go to heaven and get your, your apartment or whatever. Like, how are you going to live when you get there?
I mean, I've always said to people, what about events that have taken place on the earth? Are you not interested?
Historically recorded.
Yes, events that have taken. Forget about history book. Forget what people have been reading, what you stand up in the church or the synagogue or the mosque or whatever. Yeah. What has taken place on you? You don't want to go there with me because for part of you telling you the book there. Oh, I'm gonna throw. When I threw my Bible in the dustbin, I didn't think I could do it. I didn't. I held the Bible over the bin. I don't care what I tell you. And I thought about it because I've been thinking about throwing it away. And I dropped it in the chute. I threw the Bible away. I said, I'm not saying it's the devil's book on it. I'm not saying that. I'm just saying that what's in there isn't doing me nothing. It's just telling me about things and other people's successes.
Yeah.
And then a next brother came to me that goes to one of these Baptist church and he's saying like, how could you do that? How could you throw away the Bible? They're in there talking about what Joshua said to Peter and what Peter said to him. And he said, I said, they're just like you. You're a human being. Yeah. Look inside yourself. So, why are you 2,000 years later talking about what they talked about?
What they did 2,000 years ago.
What about the now?
Now.
No, because they're stuck in it.
And the programming, because you've been made to believe that you're doing something so terrible.
Programmed.
But it's just a book, if you really break it down. But they don't see it as a book. They see it as, this is the word of God, and I must obey God and do as it says. If I don't, I'm going to hell. But they don't question, why would he, a loving, caring God, want you to go to hell when he can't give you answers to explain how you should live and govern your life? When there's gaps in that book, or the Quran, because it's the same thing. Because they put the Quran at the highest shelf in the house, and you can't, you got to treat it like it's something so valuable. We're not saying the information, it's about the information, not the book itself. But someone had to put the information in there. So, yeah, Wu-Sabat just deals with actual facts, deals with life today. We're living today, and you're writing your story as you go along. Not his story. No. It's our story. Your own story every day. Yeah.
Because the world did not stop when Jesus died.
100%.
So it did not stop when Moses died. It did not stop when King Herod died.
Or Muhammad or whoever.
Or Muhammad or Nebuchadnezzar or even Queen I've just put whatever name when she died. It didn't stop there.
No. It's not going to stop when I'm crossover,
when we cross over, it's going to keep going.
So the generation to come, the younger people, do you think they're going to follow and listen to what we've been teaching for the last 6,000 years?
Why are you doting on that? use what you know and set it for those in the future.
That's right.
Do your bit. Don't try to do other people's bit that's already been done. And Joshua said to this and this and Paul came and he said to, I said, you're big man, you got,
it's like
you got
Chinese
kids.
whispers.
Yeah, I said, oh, he said, but when Joshua said in verse 24, God forgive me.
That's why we say
forgive me.
They're all the book of the dead, because all the people in there are dead. And you can't be a dead person or thing and be useful today. So you're alive, you're living. Live your life and live it based on actual facts and truth. You see, not why based on hearsay.
But you see why they will not move forward. They cannot. They are stuck in that book. Everywhere they go, they're back in. They don't understand. They're literally turning and facing and going backwards when they're doing that. Turn on your own axle. Look forward.
Yeah, absolutely.
What are you going to do in this time? That's going to make a difference.
That's what matters, and that's what we've got to do.
They've gone back. They won't stop talking about it. He said this, and Jesus is going to come through the clouds one day and come.
But that's the thing. Even scientifically, just let's break that down. Like, make it make sense. How is he going to come through the clouds? Where is he coming from? This is basic questions. How is he going to travel? But you see, because of religion and belief, he can do anything he wants.
Can do anything.
Anything. And you say, no, he can't. And they say, tell me something he can't do. Well, he can't be God and be himself at the same time. And then separate himself and be in heaven and be down here, die on the cross, call and ask himself to help himself, to go back and sit on the right-hand side of himself. It literally makes no sense, but you have people that would rather fight to be right than to accept and be humble enough to learn and just study and get the right knowledge. And that's why we're here. Whether you accept it or not, the facts are going to be the facts. Whether you accept you're breathing air or not, it's still there and you're still breathing it. So, Wu-Sabat is simple.
I've always said, we're going to witness things in our lifetime here, happen on earth, before it's our time to cross over. One massive thing where a lot of people are just going to stand there with their mouths open like...
Yep, exactly.
They're just going to stand there with their mouth open and ain't got a thing to say. All what you've read, all what you hold in your hand, yeah? And you're saying, this is that, and this, you bet, rather than you being proactive and looking around you and making sense of things, people that are touching the ground, and people are saying like, look, that ground is the ground, this is the table, this is a bottle of water. You know, oh no, it's in the spirit, it's in the spirit. They're going to be brought to such an
absolutely. Between now and 2030, we always tell you guys,
mark my words.
You will see it. You will see it.
Mark my words, that's going to happen.
Yeah.
It is actually to watch them rot. They're rotting themselves. They're not utilizing their... But this is why we're only using, 30% of our brain?
We're not even using that. Because 10%. This is what I'm saying, that by upgrading yourself, because we are actually holographic computers. We're programmable. And this is why the negative programming is work to keep people in a state of belief and not knowing, and in a state of not progressing, because if you don't use it, they say you lose it. If you're not using your brain, it just gets dumbed down. So we're in a stage where you have to learn, you have to study. It even tells you in their books that it's it says learn from cradle to grave. So you're constantly learning, you're constantly studying. No one knows everything. So to be stuck in a situation where you don't want to hear anything, don't want to know anything new, that's why I said, let's call in the living dead. You're actually just not progressing, you're not changing.
Surely you could see how people are hooked onto the Bible, like hooked on coffee. Because when you get married, you go to a church. when there's a funeral,
Or
you
the
go to
registry
the church,
office. No.
or but can you see how the Bible is wedged into all of that?
Weaved into every facet of
Weaved
society.
into you
Yeah.
cannot. It's in your DNA, the Bible. So when you sit down there, oh, what are you gonna do? You get married? Oh, in the church. Oh, yes, because it's the best place to get married. Oh, you die. You got to go to a church because this. And we understand, and we can see it from the outside looking in. Imagine when you're in there, you can't even see.
That's what I was
you're
saying
doing.
about the program. You have to reprogram yourself, and your DNA, your mind, everything is reprogrammable. So all you have to do is get the right information, and that's what Wu-Sabat is here to do: give you that information to make it make sense. So,
I'm a Christian.
You're thinking.
You know, I'm a Christian. Oh, are you a Christian? Oh, you're a nice person. Oh, you're a decent person. Oh, you're a Christian.
Yeah.
You have no idea what being a Christian is.
And if you start to just probe, okay, let's analyze that. When did that term first come
What
into
is
being?
it?
What
Yeah.
is a Christian?
They don't even want to go back. Jesus. Oh, don't mention Jesus. Oh, Jesus. Because that's another thing. You see, they can't go back to face the historical facts.
It's ego, isn't it? It's not wanting to
They
be
will
wrong.
not.
And
Yeah.
there's nothing wrong with being wrong.
not
As
accept
a
it.
child,
They will not.
you make mistakes, you learn, you fall, you get up,
Yeah.
you keep going.
You keep
But
going.
people don't want to accept they were wrong, or that we're just talking about, the scientific world. Accept you were wrong. Accept that, the world is not flat.
Yeah.
Accept certain things that have been proven scientifically.
Yeah.
And just, I've never understood why people find it hard to say I'm wrong or accept they were wrong,
Just
because
accept.
it doesn't kill you, and just say, you know what, I'm going to start again. I'm just going to learn.
I was brought up in the church.
We're all able to learn, so I've
Oh
never
my
really
God.
understood that. But that's the ego, and the ego is a very powerful thing within people, that they'd rather be wrong and strong
Wrong and strong.
than to just study and learn and move on. But yeah, it's been a pleasure once again. I'm sure we're gonna have another
Isn't
one.
it?
But it's always very, very
Yeah.
interesting speaking.
Yeah.
On a much more we call it higher level conversations, because that's another thing, dealing with frequency and vibration. When you're speaking with people who are just on that low vibration, it's like it doesn't really give you that energy or motivation or like to want to learn and do more. When you speak to people who they're looking at solving problems for humanity, solving situations that are going to help everyone, uniting people, coming together to solve problems and build for all of us and build for our future. That's what Wu-Sabat is about.
Yeah.
And even doing that was a threat to the status quo, because you like you say, you break away from having to get married in the way
in
you
the circle, when you die, when you get
go through that whole
christen
the christening the children, all
Oh
these
my God,
things you're
where's the
liberated
structure?
from.
Yeah.
So, and it ties into money, that you lose, they lose money as well. So there are some sinister objectives to why they want to keep people dumbed down and programmed on belief, because belief is also an industry that makes money from people just based on ignorance, So imagine no Bibles will be sold, no crosses, no Qurans, no prayer mats, none of that, none of the fake holy water that people...
You couldn't have that.
There's so much that, that affects the economy, but we could utilize that in a much more useful way. But Neville, as usual, it's been a great pleasure speaking with you. Until next time.
Till next time, take care.
What?
See you soon.
Wadu.